Hey everyone, today we'll be going over LeetCode problem 14, longest common prefix. In this problem, we need to simply write a function in order to find the longest common prefix amongst an array of strings. If there's no prefix in common, we need to return an empty string. So we have here two examples which I have rewritten to the side. In the first example, we have three strings in our strings array: flower, flow, and flay. And what we need to do is find the common prefix among these three strings. So in our algorithm, what we will do is initially take our common prefix to be the first string in our array. So we have flower as our first string in the array, so we're going to take that to be our common prefix initially. Then what we will do is go through every other string in the array and go and chop off the part which is not in common between the two strings. For example, we will start with flow. We will start with the character at index 0 in flow, and we will check to see if the character at index 0 matches the character at index 0 of our current common prefix. So we see that we have an F at index 0 in flow, and the same thing in flower. So these match. We then move on to index 1. We have an L and an L, which match. We move on to index 2, where we have an O, which matches as well. And at index 3, we have a W, which also matches. When going on to index 4, we see that flow has no more remaining characters. So we can conclude that the common prefix is now flow. So this E and the R get chopped off of our common prefix. So what we will do is modify our common prefix, and then go on to compare with the next string in our strings array. So we have modified our common prefix, which has now become flow, and we're now going to compare with the third string in our strings array to see what the final common prefix will be. We start again with index 0. We see that the F matches with the F. At index 1, the L matches with the L. But at index 2, we have an I, whereas in our common prefix, we have an O. So once again, from the O on, we will chop off whatever we have in our common prefix. So the O and the W get discarded. We would now have FL as our common prefix. We would be done iterating through our strings array, and so we would return this common prefix, FL, as our output. Let's do the same for the second example. We would initially set our common prefix to be whatever first string we have in our strings array, so dog. We would then go on comparing with the following strings in our array and see if we need to chop off any portion of our common prefix array. So we would start with race car. We would start with index 0 in race car, and we'd see that we have an R, whereas in our common prefix, we have a D. Therefore, from the D on, we need to chop off whatever we have in our common prefix. At the end of this round, when comparing with race car, our common prefix would be reduced to a null string, and so there's no need to go on comparing with the remainder of the strings in our array. We can simply return this null string as our output. The time complexity for this algorithm is O of n times m, where n is the average length of our strings, and m is the number of strings in our strings array. In fact, we saw that we are going through each and every character in each and every string in the worst case scenario in order to compare with our common prefix. We're now ready to write up this solution. So we're going to start off our code setting our common prefix to be equal to whatever string we have at the beginning of our strings array. So we're going to take whatever we have at index 0 to be our common prefix. Then we're going to go through each and every string in our strings array and go through each and every character in each of these strings. However, we know that the common prefix can only be as long as the current common prefix, so we don't actually need to go through the length of each and every string in the array. We can just go through the length of the current common prefix. Now, what we will do is check to see if the character that we are currently seeing in the string in the strings array matches the character at the same position, at the same index, of our current common prefix. So first of all, if we are out of bounds for the current string we are looking at, meaning that the current string is shorter, then we know there is no match. Or the other case is where the character at this position is not the same as the character as the position in the common prefix. So in both of these cases, we know that we do not have a character which matches, either because we are out of bounds, or the character at this position in a prefix is not the same as the character at this position at the current string. So what we need to do is chop off the portion of the common prefix which no longer matches. So we're going to take prefix to be the substring which goes from 0 up until, but not including, this current index we were looking at. And after which we can break, meaning we can move on to comparing to the next string. So we'd break out of iterating through the current string, but not this outer for loop, which goes through each and every string. At the end, when we're done with this iteration, we can return prefix, which is the common prefix we have found at the end of all of the comparisons. Again, we are iterating through each and every string, so this will be our M, and we are iterating through each and every character in each and every string, so this will be the average length of the string, or our n. And this will make our overall time complexity O of n times n. Let's make sure this runs. And we see that it works efficiently. Thank you so much for watching this video. If you enjoyed it, please subscribe to my channel. I'll see you on the next one.